So let's work with the first defining formula, xi minus mu squared, right? So we have xi minus mu squared. All right, we can do it as this is xi, right, minus b12, but I want to lock it by pressing function 4, F4, and then square it. So once I'm done with this, I can easily copy Control C and Shift down arrow to select all these and Control V to paste everything. And of course, everything is positive, right? Just a double check because it's square, so it's positive. Yeah. And the formula has us find out all the squares, and I have the entire term here. And all I need to do is to find the average. So if I average up all the squared differences, we should get the variance, which is 100.4444, which is, I think, what we manually verified as well, right? So at the bottom here. Let me revert back to, yeah, over here, 100.444, right? Now, let's try this right-hand side formula, which is very simple. Let us perform xi squared, right? So basically, that's to square b2, and then we copy this. Of course, the numbers will be very huge. Yeah? And what we do is we take the average, then minus the square of the mean. So what is that going to be? We take the average of all the squares here, all right? And then we minus b12, and which is to be squared, all right? So answer is, of course, exactly the same as if we had first squared the differences, then average it, because it has to be, right? Now let's try to treat x as a sample. So I'm just copying the data over to the left side, to the right side, sorry. Okay, and I want to say mean of the sample. Okay, we're going to treat x now, same data. We are treating it as sample. Now, of course, we cannot switch. Down here, we're just playing with the numbers. But when we perform the measurements, for example, if you're measuring the weight of apples or the height of students or whatnot, and we recorded 100, 102, 98, and so on, we have already decided whether we should treat this data as sample or population. So we cannot change that after the data measurements. But over here, let's suppose we started from scratch all over again, and this is just a sample. So we like to calculate sample variance, right? So the mean is done the same way. Notice it's the same formula, but the notion, that means the way we interpret it, is going to be x bar. All right, so don't just because the formula is the same, which means it would give you the right to call it population mean, even though you treated it as sample. That's not true, right? So we have to be consistent. We are treating x, the random variable x, as a sample, so we have to use x bar accordingly, even though Excel's formula is the same. So next, we're going to calculate same thing, xi minus mu. Well, no, not mu, x bar. However, the x bar and everything is exactly the same in Excel, right? So we can copy and paste, or we can just say G2 minus this one, and then F4 to lock it, and then square. Okay, and the numbers will be exactly the same as in my column C. And finally, what we want to do is to sum up everything and divide it by n minus 1. So I cannot use average because that would divide by little n. And what I do is I would sum up everything. So I will sum up everything. Okay. And divided by, I have 9 items minus 1, right? So instead of manually counting, I can also say, ask Excel to count. Count how many numbers are there. All right. And minus 1. And for that reason, I have to add a bracket. Minus 1 is done. And the denominator. Okay. So the sample variance is larger than the population variance, even though it's the same data. All right, and that's it. That's the sample variance. Okay, and of course we can calculate the population standard deviation. Let's do that last. But let's work on the last formula here. This particular one, right? So again, we're going to have xi squared, which is basically g2 squared, and we keep repeating that all the way down. All right. And now what we want is to say, well, sum of all these guys, all the squares, close, divided by n minus 1. So count of uh, all these guys here. Well, I'm going to have an n somewhere, right? So let me have an n somewhere. Let me just call n this guy, right? So n equals to count of how many pieces of data there are. Okay, like this. Okay, so then I can change this into just simply referring to my G13. That would do. All right. So now it's way easier. I would say sum of all these numbers here divided by n minus 1. Okay, so that's G13 minus 1 minus bracket n itself, G13 itself, divided by bracket G13 minus 1 times the square of the mean, which is to say G12 here, that's the mean, square. Yeah, okay. So it looks a little bit messy here because it's just compacted, but I'm just implementing this term here. Okay, so sum of this x squared terms, my column I divided by n minus 1, right? So if you have another n minus 1 equals to 8 here, that's even easier. Minus of n over n minus 1 times the sample mean, which is my G12 squared. That's all. And we get the same number. So it has to be the case because mathematically this is proven, right? Then finally, we did want to also finish up the calculation with the population standard deviation and the sample standard deviation. So the population standard deviation is going to be the square root of the population variance, and the sample standard deviation is going to be the square root of the sample variance. Now, Excel also has its own formulas, right, to calculate variance. So let me do this here. Over here. No, sorry. Over here. So population variance is var dot p and sample variance is var dot s. So population variance of the original numbers, original measurements, straight away it gives you the answer, right? And if you don't want to say square root of the var dot p, you can always directly say standard def dot p of the original set of numbers, and it will do the right thing, divided by n rather than n minus 1. So similarly for sample, we can say var dot s, right? You're going to treat this x set of numbers as sample. Var dot s will give you the sample variance, and SDTV dot s will give you the sample standard deviation. And using formula-based calculation is nice because, for example, if we say, oops, sorry, my 100 wasn't actually 100, it was 90. Sorry about that. If I type 90, you notice all the numbers will change immediately. It gets updated, all the results will be refreshed, right? But if you do another way, which is the data analysis way, there's a package called data analysis. All right, so you can just select the descriptive statistics and say that my input range is over here, the original data. It's in column form. There's a label in the first row, so please skip the first row. And then you say output and put the whole answer here, all right, somewhere here, and then put enter. And show me the summary statistics. The rest, no need. And then you get a whole summary of the average, the population mean, let me see, standard error and all these that we haven't talked about, the standard deviation. Notice that this is about the sample. All right, so you cannot have the data analysis module give you the population for a simple reason, because most of the time we use Excel is to process captured data, sample data, survey data. So almost, majority of the applications are all about processing samples. So when you do data analysis, there is no option for you to say treat this data as population. There's no such thing. So all the standard deviation, all the variance, and then it's nice. It says sample variance. All right. So will all be about the sample version of the definition. So keep that in mind. All right. So all these will be all about the sample. Now, the other thing is when you tweak the numbers, you say I typed wrongly, it's not 74, it's 94. The values will not be updated, obviously, because they are static. They are not formula based. Yeah. So you just have to weigh the pros and cons. Which one is better for your applications? Okay, just want to show you the Excel version of calculating uh, all these so that you don't worry so much. Okay. See you in the next lesson.